Start recording. Okay, good evening, everyone, and welcome to the data modeling concepts part. We already discussed the basics, and today I'm going to continue from where we have stopped. Right, and then with today's session, I'll complete the modeling part, and then we will have a small assessment, in the sense the lab that you can work on. Right. So the last time we discussed about the database design aspect of this. And when we talk about the database design, the very first task is you gather the requirements. I think you have discovered that topic earlier as well. But in data design, usually we collect the data requirement to make the database design. So usually you will collect something like this. So this particular description is collected for a company database. So you can see there are data requirements for departments, projects, employees, and also the dependents. Okay. So there are three parts that usually we talk about in database systems. Usually you will cover in more detail. Since the software engineering methods, we talk about how to model, we revisit this. So this is actually continuation from what you have learned already. So there are three things we are going to discuss. One is conceptual model. We call it a very high level overview of the system, right? In this particular case, in data design, we are going to use what we call ER diagram. Everything we are going to represent as entities and relationships. So last time we covered the concept of entity types and then attributes, right? Today, we are going to discuss the relationships and also the type of relationships and also the total and partial participation. We call cardinalities, right? So that's what I plan to cover. So usually I would like to have some questions. Language doesn't matter. You can talk to me in any language you want. And then you can also use the chat session to pose any questions related to the discussion we are going to have, right? Okay. So what are the concepts we have discussed early? We discussed like how to, given a description like this, we discuss how to identify entity types, entities. So we can see department is an entity. So it could be a person or a thing that we want to represent. And then we have project, we have employee, then we have dependent. And then we have something called attribute, which describe the entities. So then we also discuss there are different types of attributes. For example, social security number is a simple attribute, birth date, sex, address, and salaries. Then we have sometimes we have several components in a particular attribute. We normally call this is as a composite attribute. Then some attributes you have multiple values. For example, if you take a car, nowadays you can see multiple colors, right? So then we can represent multi-valued attribute, which means that you will have multiple values. Then there are things called derived one. A typical example is like if you have a birth date, using a birth date, we can find age. So if you have an attribute like age, so that will represent using dash ellipse, which means derived attributes. So those are the ideas that we have discussed. Then among these attributes, we have to select or we have to underline, we have to identify at least one key attribute. So you can see here, social security number is a key attribute. In department, name and number, both are key attributes. So you have unique values simply. Project, we have name and number, right? But some cases, like dependent, we might not be able to identify any key attributes. Then this becomes a weak entity type. So that's why we have a double rectangle shape here. So when you have a weak entity, there will be no key attribute. We have what we call partial key. So to find the key attribute, usually you go with its relationship with what we call participating entity type. So in this particular case, dependent, depend on the employees, right? So that's what you will see here. Since this is relationship also dependent, so you can see a double diamond shape block is given, right? I think this is what we have discussed in the last session. Let me continue the discussion of what we have discussed. Now, today we will look at relations. For example, now I am a lecturer and you are students. So I, as a lecturer, teach for you, right? So the relationship between you and me is teach. So usually we can represent using graphical representation. Let's say I can have, okay, teacher, right? And then I can have student. So these are like entities. So to represent entities, we know we can use rectangle blocks, right? So let me put a rectangle block. Okay, teacher is an entity, or we can say entity type, and student also entity. And as a teacher, I will conduct courses for you. So one relationship is I teach, right? So let me put, right, relation as a, I will teach for you, teach, right? So what I can have is, okay, we can have a relation or relationship. And then we can have lines which will connect the two, which indicates that, okay, teacher and the students are participating in this relation. Simply, this is what we are going to have. So for example, if you have an employee is entity, then we have a project. So employee works for project. So the works is a relationship. Similar to that, employee manages some department, like head of the department. So the relationship between the employee and the department, you have something called managers, right? Okay, so I hope you got the basic understanding. Now let me go to my ER diagram. So in this particular case, if you go back, you can see different relationships. Employees works for department, employee manages department. You can see in between same two entities, there can be more than one relation. Employees work for department, at the same time employee manages department. Similar to that, you can see employees works on projects. And we know department controls projects, right? Sometimes this relationship can have what we call recursive relationship. Usually we have distinct entities, but here this relationship is within the same entity type. So it's like I'm supervising, right? Sometimes, let's say lecturers, there are senior lecturers who look after the junior lecturers. So it's something like that, right? In schools, for example, teachers, there will be master teachers who look after the others. So this is with the same. So we are going to have supervision is the relation with the same entity. This is called recursive relationship. And since you have the relation with the single entity, we will mark the both side, what their participation is. One side is a supervisor, the other side is a supervisee. Right. So with that said, I hope now you understood about the different types of relations, right? Okay. Next, if you look at, we need to talk about what kind of relationship they have. We talk something called maximum cardinality, which means maximum number of instances are participating in a relation. Okay, let me explain. Now, for example, let's say I have, right, one side we have teacher, the other side we have, let's say, university, we'll say lecturer. So let me put this in as a text. Okay, let me take, okay, I will put it like this. Okay, let's say we have lecturers, and then we have universities, right? So now lecturers, let's say the works for universities. So I can have a relationship called works for, right? So let me put down the blocks. So this is entity, and this is also entity, but this we know this is a relation. And then we have connectivity. Okay, lecturers works for university. Okay, right. The next question is, what kind of relationship you have? What is the maximum number of instances that could participate here? So this is how you are going to understand this. So take one lecturer. Take a lecturer. How many universities a particular person can work for? Yes? What do you think? Take a lecturer. How many, usually universities you works for? Yes? Usually it will be one university, right? For example,
One to many.
yes, exactly. So from this side, when you take one, right? So you work for one university. Take a university. How many lecturers works for the university? There are many, right? So I can put N or M, doesn't matter, which will indicate that, okay, this is one to many, or in other words, we can say this is many to one relation. Maximum number of instances are participating. We can say, okay, it's one to many. Okay, so let's say that, okay, I'm going to remove this. We have vice chancellor here. Okay, now can you tell me what kind of a relationship we have? Again, take a one vice chancellor. Usually, yes, works for one, right?
1 to 1.
Exactly. The maximum is one. Take a university. Sometimes university might not have vice chancellor, but the maximum vice chancellors you can have is one, right? So the relationship should be 1-to-1. Okay, good. I think you are getting it. What about the lecturers and students? Let's say lecturers.
Many to many.
It's many to many. You take a lecturer.
1 to many.
And teach for many students. Take a student can learn from many lecturers, right? So both sides we have many to many. Good. So that is what we call maximum cardinality. That means maximum number of instances can be participate in a relation. Good. Next one. We call minimum cardinality. Right? Sometimes this participation could be optional or mandatory. This is what we want to figure it out. That means if all the instances are participating, we call it mandatory. If only some of the instances are participating, we call it's optional. Right. Now tell me, if you take a vice chancellor, right? Vice chancellor is working for a university. Is it optional or is it mandatory? What do you think? You call a vice chancellor. When you call a vice chancellor, what do you think? All the vice chancellors, if you take it, they should work for a university, right? So is it optional or is it mandatory then?
Mandatory.
It should be mandatory, right? So if it is mandatory, then we draw double line here. Take the university side. Take all the universities are having vice chancellor.
No.
What do you think?
No, sir.
Okay, so these are the things that you need to sometimes make a decision. So the answer could be both yes and no. Let me explain why it could be no, why it could be yes. Right? If you take a university, usually we have to have a vice chancellor, right? Somebody who will be managing the university. But if it is in a private university, that could be a chief executive officer. You might not call a vice chancellor. So depending on how you interpret it, you can say yes or no. So assuming that, let's in general, usually all the universities, you have somebody who's taking care of the administration part of the university, which we call the vice chancellor. Assuming that, we can put a double. But remember, these are like arguable, and as a designer, you have to make the decision. So if somebody put a single line, that is also correct. If somebody putting 2 lines, that is also correct. But remember, you have to make that assumption and you have to write down the assumption. You will say that, okay, there are some universities without a vice chancellor. If you say like that, then it will be partial. If you're assuming that all the university you have vice chancellors, then it's total, we call it, right? So that's how you have to determine. Okay, so that's about, okay, entities, relationships, and also the cardinalities, right? So I hope now you should be able to understand, right, all the points that we have decided. Okay, let's try to understand again. Now, employees works for department. Take a one single employee can work for one department. So we have one here. Take one department. Department can have more than one employee. So this is N. So this is many to one relation. And we know that all the employees should work for a department. So you have a double line here. All the department you have to have employees. So this is double line. Okay, now let's take this one. Employees, managers, departments, like you are heading in. So if you take one employee, you will manage one department. We'll assume, there's assumption. We assume that if you take a particular person, he can work for maximum of one department. So that's why one here. Take a one department, how many managers you can have? We'll assume one. If that is the case, we say this is one-to-one relation. Now say, not all the employees works as managers. So that's why we have a single line here. It's called partial participation. Not everybody can be prefects, for example, let's say in a school, right? So you can become, not all the students can become a prefect. So it's a partial participation, right? So this side, but department should have a manager, every department. So this is double line. So that's how we are getting single and double. Okay, look at the supervision. We know not all the employees works as supervisors. හැමතැනකදීම boss වෙන්න බෑනේ. හැමෝටම bossලා වෙන්න බෑනේ. ඒ වගේ තමයි. ඊට පස්සේ අපි යටතේ ඉන්නවා. අපි කියන supervisors. හැමෝටම supervisorsලා වෙන්නත් බෑනේ. bossලාත් ඉන්නවා. So therefore, you can see here, we will have single lines which connecting the supervision entity type. So that's how we can work on maximum cardinality and then minimum cardinality, right? So I hope you understood the idea that I would like to discuss, right? Okay, now how many entities can participate in relations? So sometimes we say, okay, you can have only two. So that means you have entities, we have relations, and then you connect like this. So mostly in your level, we talk about, okay, you have a relation, but you will have two entities, which we call binary. So this relation is a binary relationship because you have only two. But sometimes you can have more than two. It can be any number actually. If you have three, we call ternary, or we can have n-ary, right? So that depending on that, we talk about the type of a degree of a relationship. So if you have two entities, then we say binary relationship. If you have three, we call ternary relationship. If you have more than that, we can say, let's say you have n entities, then we can say it's n-ary relationship type. Okay, so I hope now you understood about the entities, attributes, relationships, as well as cardinalities. Okay, next. When you draw, there are different notations are there, but this is something that we have, that you can witness in my notes. So usually in ER diagrams, you define what we call the schemas, not particular individual instances. Usually singular names are recommended and uppercase for entity type. So you can notice that in this note, we have used all capitalization for entity types. Then attribute names, capitalized, which means you start with the capital letter. Then role names, that means if you have a recursive relationship, usually we have two sides. Okay, we use supervisor and supervisee. Then cardinal ratio, that means type of relationship. We said one-to-one, one-to-many, many-to-one, many-to-many. Then you can talk about partial participation using single line and total participation using double line. And it says at the end, if you cannot determine all these requirements, you have to make necessary assumptions. So that's why I said you have to, decide, right, when you have not given enough information. So sometimes we can give a description, and then based on the description, you can determine, right? Or you have to, if you cannot determine, then you make the assumptions to make it the description complete. Right. Next part is we have discussed now logical diagram of a database design. Sorry, conceptual diagram. Then the second one, we have to create what we call the logical diagram. You know that when you're creating a database, you have to create tables, right? Okay. I just want to discuss, let me stop this recording. Okay, now we learn one kind of a notation, right? There are many notations people come up with. So therefore, when you refer some different notes, if you see different notations, don't worry, and that's normal. In software engineering, what we want to discuss is the same thing. Different people use different notations, but the ideas are the same. Okay, for example, we have entities and relationship, and this is what we have discussed. And sometimes you might see like this, no attributes, but just entities and the relations and also cardinalities. This is possible. So this is another representation. Then different notations. Remember, we use the one-to-one, one-to-many, many-to-many relations. But then there are people have defined how you may use them. So instead of one-to-one, one-to-many, many-to-many, some people use one and only one. And graphically, we represent like this, right? We don't have double lines, so 1 and 2, but you will have 1 and 1 here. So simply 1 and 1. That means minimum is 1, maximum is 1. So we just put 1 in UML notations. I will explain what those are. Second one or many. You can see here, 1 or many, right? That means if you look at the minimum, you have 1, but you can have any number. So that is many. Then 0 or 1 or many, right? So the minimum is 0, then you can have many. So we'll put 0 and some dots and the asterisk, which indicates this. Then you can have 0 or 1. So the minimum is 0, maximum is 1. And this is called cross-foot notation. And if you refer some of the books, the designs are put in like this, okay? So these are the things that you should be familiar. Don't worry if you see different notations in different books. That's normal. And you are going to witness various something like this. Okay, using cross notation, here are some examples. Customer places order, right? So if you take one customer, can places 0 or more orders, but definitely if you take an order, we have to have a customer. So that's why we have 1 here. And then another example, order includes items. So if you take order should have at least 1 or more items. But if you take items, that ordered item should belong onto one order. Okay, next one is very interesting. Employee has spouse. So if you are working in a company, maybe you will have minimum is 0, but that means you don't have a spouse. That means you don't have a partner. Maximum is 1, which means, okay, you have a spouse. Take the spouse side, the minimum and maximum both are 1 and 1. Definitely you have to have an employee. Last one, employees assigned to projects. So employee can work assigned to 0 or more projects. A project also can have 0 or more employees. So that's how usually we interpret those different notations. Right. But just ER is not enough. An ER diagram cannot represent specialization and generalization, which you talk about in object-oriented principles. So what do you mean by specialization? Something like this. Now, for example, in a university system, we can have, okay, let me put like this. In university system, we can have, okay, lecturers, and then we can have instructors. So these are like two entities, but then you can generalize saying, okay, we can have person, because we know that lecturer is a person and instructor is also a person, right? So these are the ideas that we can talk about in enhanced version of ER, which we call EER model. So ER model, we usually incorporate these superclass, subclass relations. Right. Right. Now, since already you have done, the next one is we want to talk about the mapping. That means you have given a ER diagram. How do you identify a relational model? That means your logical model. Can some of you tell me, how do you map regular entities? How do you map weak entities? How do you map one-to-one relations, one-to-many, many-to-many? How do you map multi-value attributes? How to map in array? That means if you have more than 2, right? Relationship types. Yes. Let me stop the recording so that you can talk. Right. So you can see here, we have employee relation, or in other words, you can say employee table. These are the attributes, and we can see underline 1, this is the primary key, right? And you can see this is SQL statement, which how to create the table. And this is what we call the physical design, or the SQL statement where we create the table. So I hope you have learned the commands like create table employee, fname varchar 15 not null, which is this one. Then middle initial character, last name varchar again, social security number, character 9, and we say primary key is social security number. So this is what we call the use of SQL for the physical implementation, or which we can call physical model, right? So I hope now you understand this, but why I show you this, I mean, to create this one, we start with a small description, we generate this one, and then we generate this, and then this can go into your actual SQL statements. But you don't have to follow the same. One thing is you can just create tables, then you have to follow the normalization rule, which I'm not going to discuss right now. But let me explain how to start from here to get this part. Okay, are we ready? Right. So I will start this, and then I will post a video on complete, mapping part. But let me start the basics. Right. When you want to do mapping part, usually we start with entities. The first, we'll discuss how to map regular entities. This is how we are going to map regular entity. So each regular entity will be a schema. That means you create a relation R, so that means every entity you are going to create a relation, or in other words, we can say table. So what happens here now? We have to create a table or a relation for employee. We have to create a table for department. We have to create a table for project. These are regular, we call it, right? So you can see here, employee, then we have project, and then we have department. So that's why we get these three, right? We got these three because they are regular entity type. Okay, that's the first part, right? Second, we say include all simple attributes of E. Okay, now you go back. All simple attributes. So all simple attributes mean birth date, social security number, sex, address, salary. And name you cannot have because it's composite, but you can have these parts: first name, middle initial, and last name. Therefore, you will get first name, middle initial, last name, social security number, birth date, address, sex, and salary. That's all, right? So up to this point, these are simple attributes. Up to this point, these are simple attributes. Similar to that, look at department. Department, we have name and number. This is not simple. So we can have department relation, name and number. So we can have department relation, name and number. So don't worry about this part, it comes later on. But in regular entity type, we get up to this point. Similar to that, project, you can see name, number, location. So project, we can have name, number, location. Okay, so that is mapping regular entity types. Okay, then choose one of the key attributes of E as a primary key. So primary key means unique attribute, but you can have only one unique attribute per relation. So therefore, we can go back. If you look at employee, we have only one. So we take this as a primary key, we underline. So we have underlined here. Similar to that, department. Okay, we have two key attributes. Take one of them as a primary key. So if you go to department, we can say this one is also qualified, but we select only one. We select department number as the primary key. Then project, again, name. Okay, we have discussed that, right? So we have to, okay. That is regular entity types. Okay, right. Next one. How do you map a weak entity type? Similar to previous one, it says you have to create a relation, include all the simple attributes. Then you will get a primary key of the identified relations, and you include it here, and then you will say it's a foreign key. Let me explain. Now, here we have dependent. This is weak entity type. So we create a relation. We include normal attribute, dependent name, sex, date of birth, relationship. Everything is included. But to make a primary key, you have to get attribute from here. So social security number, you put it here. Combining these two, we can identify the key attribute. Okay. So we discuss how do you get regular entity types, weak entity types. Next. Now, The next point that I would like to highlight is how do you map one-to-one relations? So let's go here. What are the one-to-one relations? Okay, here are the one-to-one relations. There are two possibilities that you can actually create. If both are total participation, we can merge. So both are not total participation. So you cannot merge here. Right? Then we have foreign key approach. To make the connection, we take the primary key and we have to put other side. Or else you get the primary key from here, you put it the other side. Which one is best for managers relation? What do you think? Let's take this primary key of this, you put it here, or you take the primary key here, you put it in the department. What do you think? It's something like this. Let me type it again. So we have two things and we are trying to map one-to-one. So employee is there. Primary key is social security number, and then we can have any number of times. One design is you take the department number and include it like this, and the department number is the primary key, and that's all. Now question is, where are you going to put? So for example, you can get, right, department number to the employee side or social security number in the department side. Which one is the best one? Let me say this is the first one. This is the second one. Which one is the best mapping? So is it to include department number to the employee side or include the social security number in the department? Yes. So remember that if you put this department number here, right? That means if you are managing a particular department, you have to put it here. This is not possible because we know that it's not everyone is participate as managers. So we can put the other way around. You can have a department and get the social security number and put it here. And this is exactly what I think you mean. So we have department, the number, and then we have social security number. Okay, guys, I think this is enough for today.